Hello folks, we are back with our next video on we were doing exercise 6.4, the approximation, and there it's now the 11th question. Let's see what the question says. Question says that it is 0.0037 raised to half. Quite complicated. 0.00, I hope I recollect it correctly. 0.0037 raised to half. Okay. The question is 0.0037 raised to half. That's quite easy. Now we know we've been doing it for quite some time. We know that we directly start with y and so on. It's very stereotyped. So we just move like that and then we'll say that let y equal to x raised to half. So that gives quickly dy by dx and x raised to n minus 1 half x raised to half. Then how about the values here? Here x plus delta x is 0.0037. That is absolutely effortless. We can get it directly from the question. 0.0037 raised to half. So that much is done. Now we have to decide the x value, a standard value which is close to 0.0037, but at the same time whose root is known. So it's very evident. 0.0037 is very close to 0.0036, and 0.0036 raised to half, we know it's a standard value. It can be fine, it can be found out, so that's perfectly okay. So I think you can take x as 0.0036. Now if that is the case, what is y? Y is 0.0036 raised to half, which is 0.06. 0.06 into 0.06 is what gives you 0.0036. So that's the value. So that's about it. Once you've got that, then automatically you'll take delta x. Delta x is x plus delta x minus x. So this minus this. It's very clear that it is 0.0001. Yeah, x plus delta x minus x. So also we will find out what is dy by dx. We had found it only in general. We will find out what is dy by dx when x is 0.0036, because you require it in the calculation. So it is 1 by 2 0.0036 raised to half, which we know is 0.06. So that way it will be 1 by 0.12. So that's your dy by dx. Now we all know that delta y is y plus delta y minus y. Also in this approximation, not otherwise, but only in this approximation case, delta y can be called as dy by dx into delta x. So therefore we land up into such a relation where values of every part we know. So we are going to substitute. Dy by dx we know is 1 by 0.12, and delta x we know is 0.0001, and y plus delta y we know is 0.0037 raised to half, and y we know is 0.06. So very easily we can find the value of 0.0037 raised to half by taking this on the other side, 0.06 plus 0.0001 by 0.12. Now let's solve this. Let's multiply by 1000 both in the numerator and denominator. Then in that case you are left with 0.06 plus 1 by 1200. Then let's try to solve that and get the answer. 1 divided by 1200. 0 point, not able to divide, so we are putting a 0. That's really not possible, so we'll put another 0 so that we can obtain another 0. Again it's not possible, so we'll put one more 0, obtain another 0. We get 1000, again not possible, so one more 0 and then 10,000. And 12 stable, if you know, it's quite convenient. We know that 12 8s are 96. So like that, it is 8 times 9600. So that's enough actually, 4 places. No, I think that's fine. So you can have it like 0.06 plus 0.0008. 4 places are there. So 0.0608. That's it. Our answer for 0.0037 raised to half is actually 0.0608. That's about it. We always take up one more. So let's take the 12th problem and see what it says. 12th problem says that it is 26.57 raised to 1 by 3. 26.57 raised to 1 by 3, and we actually have no time to actually think at all, because it has become so stereotyped to us that y is x raised to 1 by 3. So like that you can quickly find out what is dy by dx. It is going to be 1 by 3 x raised to minus 2 by 3. So also we can have the x plus delta x, etc. So your x plus delta x is always given there, we don't think at all. It is 26.57, and correspondingly y plus delta y is the this thing with the exponent, that is 1 by 3. That's it. From the given itself you get that. Now we have to decide the x. X is some value that is close to x plus delta x, whose value after putting the exponent you should know. So 26.157, exponent is 1 by 3. 27 should be okay. 27 should be fairly okay. 27 we can take, so that you will get y as 27 raised to 1 by 3, which is 3, because 27 is 3 cube. So like that, 3 cube into 1 by 3, it will give you 3. So that is y value. Having got this, automatically you can find out delta x. X plus delta x minus x. So this is little complicated. 26.57 minus 27. We'll do it little judiciously. See, 27 minus 26.57. The answer is going to be a negative answer. So let's get the subtraction. 7 becomes 6, 10 becomes 9, 0 becomes 10, 10 minus 7, 3, 9 minus 5, 4, and then everything 0. So actually this is minus 0.0043. Sorry, minus 0.43. 43. Okay. Now having got that, we will always also calculate delta dy by dx at the standard value, that x value is 27. So let's calculate that. Dy by dx is 1 by 3, 27 raised to minus 2 by 3. Now we all know that 27 is 3 raised to 3. So when we try it now, this will get cut. So it will be like 1 by 3 into 3 raised to minus 2, or 1 by 3 cube. No, the 3 raised to minus 2 will come to the denominator. So that is 1 by 27. So we all know the relation now, that delta y is y plus delta y minus y, and this, because it is getting approximated, can be called like this, dy by dx into delta x. Now all these values are values which we know, so we are going to substitute. Dy by dx for us, it's 1 by 27, and delta x for us is minus 0.43. Y plus delta y is what you have to find, 26.57 raised to 1 by 3, and y we have found out is 3. So in order to get our 26.57, we are trying to bring the 3 on the other side. So it will come to 3 minus 0.43 by 27. So it's a matter of dividing this and finding out the answer. It's only that much. I think I'll borrow this place here and try to do this, since there is no working space here. I think I'll do it over here. 0.43 divided by 27. 0 point first, so that I can take the 4. 27 obviously cannot divide 4. So you can put a 0 and take 43. Now 27 1 times is 27. How much is remaining? 13 and 7 is 6. So this is 3. So 1. Because of the decimal, you can put a 0. 160. You know, whether we know the table of 27, fast we can write. 27 5 times is 135. 27 5 times is 135, if my calculation goes right. So because it is 5 times 6 or 7 should be okay for this. So let's try maybe 27 6 times. 6 sevens are 42, 12 and 4 16, 162. Narrow margin, we missed it. So we'll have to take 5. I hope it's correct. So 42 4 12 plus 4 16, yes. So 5 times it is 135. Now let's check. 10 minus 5 is 5. 5 minus 3, it's 2. So actually, you can stop 3 decimal places. Maybe we'll do 250, should be 9. 9 or 8 or something. 9 we will try. If it doesn't work, we'll go for 8. 7 nines are 63, 6 carries. 18 and 6 should be 24. 243, fine. 9. 0.0159. Let's try to put it here. 3 minus 0.0159. Let's see how this works. Becomes 2, 10 becomes 9, 10 becomes 9, 10 becomes 9, 10. So 1 here, 9 minus 5 is 4, 9 minus 1 is 8, and 9. So 2.9841 is the answer for 26.57 raised to 1 by 3. I'm sorry for the space borrowing technique over here. This we have borrowed the place for this calculation. That's it. So 26.57 raised to 1 by 3 gives an answer as 2.9841. So that's it. That's all for these two problems, that is problem number 11 and 12. With more problems, we'll meet in the next video. Thank you.